Okay, now let's talk about some basic calculations. The first one that I want to look at is addition. To add values in Mathematica, you just do, let's say 1 plus 1, so 1, and then plus, and 1 plus 1, and then hit Shift-Enter to evaluate that line, and it'll give you the output. That's all there is to it. Let's see, let's do multiplication. Subtraction, basically the same as addition. So if I want 1 minus 1, Shift-Enter, then we get 0. For multiplication, you have a couple of options. If I want something like 2 times 2, just type in the asterisk above the 8 key and use that as your multiplication symbol. If you have variables in your product, so for instance 2x, I can just type 2x and it'll interpret that as 2 times x. I could also put the asterisk in there. That's also viewed as 2 times x. You'll see that we're getting the same output in both of these. However, if I want to do x times 2, I can't just hit x2. It's going to view that as a variable name. So I can either put a space in there and it gets interpreted as 2x, or x asterisk 2, like that. If you have numbers that you're multiplying together, so for instance 3 times 4, if I do 3 space 4, you'll notice that Mathematica goes ahead and inserts this multiplication symbol in there for me. Then I can hit Shift-Enter and get my output. I'm not a fan of using this cross sign for multiplication. I'd rather see it use a dot. We're not in elementary school anymore. This symbol is used for taking cross products and has other meanings. So I would rather see a dot in there, but if that's how you're getting it, that's fine. However, I don't want to see you using the palette to insert that symbol in there, but if you're just hitting space and Mathematica is putting in, then that's fine. I would prefer that you use the asterisk, though, if you're multiplying 3 and 4 together. Let's see, other operations. So we can take exponents. If I want, say, 2 raised to the 3rd power, I can use a caret above the 6, and we get 8 there. If we want e to a power, so like e to the x, there are a couple of ways to do that. You can either type exp, and then in brackets, whatever you want in the exponent, so that, we get e to the x, or e squared is that. If we want a numerical approximation, we can either put a dot right there, or you can do a double backslash and a capital N. That'll give a numerical approximation. There are other ways of getting numerical approximations. You can also get that E symbol from the palette. So if you go to Palettes and then Basic Math Assistant, click on that. Either Basic or Advanced, either one. Here is the symbol E, exponential. You can click that, and then you can do a caret and 2, for instance. You can also, in these palettes, notice there are other ways to, you can have an exponent like that. So if I want 2 cubed, I can hit 2, press that right there, and then a 3, and we get 2 cubed. There are keyboard shortcuts for that as well. You'll notice here the keyboard entry is to hit Control-6 to get a superscript like that. So instead of the Shift-6 to get that caret, Control-6 will give you that nicely formatted superscript. I don't have a preference either way. When I'm typing things in, I'll usually do just the single line input. I'll use a caret. If I have an exponential function with a lot of stuff in the exponent, I'll probably use the exp function instead. But however you would like to format that is fine. For logarithms, there are similar commands. So if I want a log, and notice as you type it in, Mathematica will suggest commands that start like that. If I want log base 10, I'm going to use this log 10 command. And then, so log base 10 of 10 should give me back 1. If I want natural log, this is one that throws people off. So natural log, you'll enter that as just log, not ln. And then natural log of, say, 2, get that. Again, if I want a numerical approximation, either just throw a decimal on the 2 there, or you can do the double backslash n. If you need a certain number of decimal places displayed, I can do n and then log 2, and let's say I want 10 significant digits, not decimals, and you can evaluate that to get the number of significant digits that you want. If I want a root, so for instance a square root, a cube root, on the palette here, you'll notice that there is a square root shortcut, so square root of 2. Again, if I want a numerical approximation, I need to use one of the options to get that. Hit Shift Enter, and we get our 1.41421. If I want the keyboard command, you can do sqrt2, and that'll give you the same thing. If I want a cube root, so let's try using this symbol. Let's say the cube root of 2. If I can get to that exponent, or that root over there. There we go. So this should give me the cube root of 2. Let's go ahead and ask it for a decimal approximation. We get that. Now, if I say -2, this command doesn't actually work. Notice it's giving me this imaginary number. I should be able to take a cube root of -2, though, and get a real value back. So let's try another option. -2 raised to the 1/3 power. That should be interpreted the same way. And again, I want the decimal approximation. We do that. Again, I'm getting this imaginary output. So if you see i's in your output, that's the square root of -1. We're getting an imaginary part of our output, and we're not going to be working over the complex numbers. So if you see any imaginary parts in there, then it most likely means that you're doing something incorrect. So there is a way to get a cube root. You can type in the command cube root, or to get the correct cube root, the real one that we want, cube root -2, and I get that, which is what we got from the positive cube root. Let me maybe go back up here. I can do, again, 2, I'll do the decimal raised to the 1/3, should also, for the positive one, work out. But in general, if you're trying to plot, say, cube root of x, or doing anything where you could have a negative input, then you want to use that cube root function. Now, what if I want a 5th root? So we're going to run into the same issue. Let's say -2 point, and then I want to go to the 1/5 power. Just getting these extra lines from the suggested input. I'll put a 5 up there. And again, I'm getting this complex output here with the I on there. So what we're going to do is take this, instead of using that shortcut command, there's actually command SURD, and we'll do our -2 point, and then point, comma, and then we want the 5th root. So I'm telling it which root I want there, and now we get the correct output. I could also use this for a cube root. Surd -2 point, comma 3, and that should give us that -1.25992 that we saw before, and it does. So if you're taking an odd root of some quantity, then most likely you'll want to use either this cube root, if that's the root that you're taking, or for any other odd roots, use the surd function. Okay, numerical approximations. I've already talked about that a little bit. So there are a number of ways that we can get a numerical approximation. I can add a decimal. I don't even need to put the 0.0 on there. Once Mathematica sees a decimal, then it assumes that you want to do floating point arithmetic, and it'll stop trying to find exact values. That can be useful when you're defining a function. Maybe you have a constant in there and you know that you're going to want decimal approximations on everything, and so you just go ahead and put a decimal on one of the numbers in there. So if I want 2/3 decimal approximation there, I could do 0.2 divided by 3. That gives me that 0.666 repeating. And I could also get that, I could do 2/3 and then a double backslash n. That also gives a numerical approximation. I can do n 2/3, just wrap the value in that capital N command. That is the same as doing the double backslash n. With this form, though, you have a little more flexibility. So if I want to see more decimal places, say I want to go out to 10 significant digits, then I can put that comma 10 in there and get it that way. Now, one thing that you may run into, so if I do, let's see, 2 point divided by 3, I'm going to go ahead and wrap this in an n command here. I'm going to do a comma 10, trying to get it to display what we saw on the line before. This 2 point and then divided by 3 is already being viewed as a decimal value, and so you'll notice that Mathematica doesn't display any more than its default there, even though I've asked it to. So if you have a quantity that's already in decimal form, then rather than using the capital N command to get it to display more, you have to use this number form command, with both the N and the F in number form capitalized, no spaces in there. 2 point divided by 3, and now I'm going to ask it to display the 10 significant digits, and it does. So a few idiosyncrasies you have to be aware of when you're trying to get it to display more than the default number of digits. If you're fine with the default, then everything works out pretty easily. But if you want to show more than that, and you have something that's already being stored or remembered as a floating point decimal value, then you'll have to use the number form rather than n. Let's look at some other algebraic operations. If I have something like x plus 1 to the third power, enter that. Now let's say I want to expand that. You'll notice that it's suggesting expand. I can type expand, and then we'll have x plus 1 to the third, close off that expand, and then it expands it for us. If I want to take this expression and factor it, I can use the factor command. 1 plus 3x plus 3x squared plus x cubed. Mathematica knows the usual order of operations. So for instance, this 3x squared, it knows to square the x first and then multiply that by 3. If I wanted 3 times x quantity squared, then I would have to put parentheses around the 3 and the x. But that's not what I want here. So I can tell Mathematica to factor that, and it does. Collect is another command that you may need to use. Expand and factor, those are fairly well-defined terms, but if you have something that you want simplified more, there is also a simplify command. So if I take this input from the factor, I'm just going to copy and paste it down here. And it's looking for another argument. So again, if you don't know what to do, look at the help, and we'll go to that. And it wants the name of the variable that I'm looking to match up here. So I need a collect here. I've got x's, collect comma x, like that. And it's not going to do any other manipulating to it. It's just going to get all of the x terms together. So for instance, if I had plus ax plus b x or something like that, and I hit collect, you'll notice there that it goes ahead and it puts all of the x terms together. So it gives me that 3 plus a plus b on that. Whereas if I were to just take this and run that without the collect, it's going to just spit it back as it was before. Oops, I didn't have the plus 1 on there. There we go. So it's not doing any of that algebra for me. Another command that again isn't extraordinarily well defined here is the simplify command. So I can ask it to simplify that expression, and here it went ahead and did the collecting. If I ask it to simplify, let's go back to the original one without that ax and bx. If I ask it to simplify that, it does go ahead and factor it for me. But factor and simplify aren't always going to give you the same thing. So you need to be a little bit careful. You may need to try to use multiple commands. If something's not simplifying the way that you want it to, try doing an expand and a factor, a simplify, whatever direction you're trying to go with that. And sometimes if you nest a factor inside of a simplify or an expand inside of a simplify or vice versa, you may get some different output. Simplify and well, collect is a little more well-defined, but simplify, just saying to simplify something, that's not a well-defined term. And so you may have to help Mathematica along to get it into the form that you are looking for.